Welcome back, and today we're going to be looking at solving multi-step equations again, but now these are going to get a little bit trickier because we're going to be focusing on the best practice for moving variables around and not leaving one side empty, meaning equals 0. The reason for the T-chart here is because I'm going to show you that you can, let me repeat that, you can solve this two ways. But I'm going to point out the best practice, meaning probably the best way to solve this before, so that way you guys have a strategy that you can use whenever you're faced with a problem that looks like this, because these can be quite tricky. Okay, so first we're going to start with the equation 2x equals 3x minus 12 minus 5x. So we're going to draw the wall, as we always do, to separate the left side from the right side. Okay, now what we want to do is always scan the problem before we start moving things around. Scan the problem and see, can I combine any like terms? Nothing on the left. I have an x here, can't combine with a 12, those are different. But I do have another x here, so I can actually combine, or what we call blend, these two x's. They're like terms. They both have x's. And now we can use the integer rule. This is a positive 3x. This is a negative 5x. So we have different signs, so we subtract. And we take the sign of the higher number. In this case, the higher number is 5, so it's a negative 2x. Bring down the minus 12, bring down the equals, and bring down the 2x from the left side. All right, so now we can start looking at this. Now, traditionally, we said that we should always move the smaller variable over first. Okay? So in this case, we're going to see that negative 2x is smaller than positive 2x. So we move it over by doing the opposite. So in this case, this works out just fine. Bring down the negative 12. Don't forget the negative sign. And we always divide last by whatever the coefficient is. Remember, we don't change the sign of the coefficient. So x equals, and remember, if you're having trouble with your signs for multiplication and division, use the triangle. We have a negative and a positive. You always go to the triangle and cover up the signs that are given. Negative and positive, cover them up. You have a negative left, so it's a negative, and then 12 divided by 4 is a 3. Is a 3. Okay? So now, this way is nice, and we're going to look at another way that students can solve this. So quickly, we combine our like terms, same process as before. So we did this, the first step was the same. So now what I see students do sometimes is they actually move this 2x over here. So it's a positive 2x, they subtract 2x. Okay, now here's where common mistakes get made. Same sign, so you add and keep. Now, what students end up doing is they end up doing this. They think they have nothing left on this side, so they focus in on this, and then they just simply go divided by negative 4, divided by negative 4, so x equals 3. Okay, that's not correct. You cannot do this because they're on the same side. Okay, so let's just focus in on this. What you needed to do here, after you cancel this out, you need what we call a placeholder. We needed to put a, since they canceled, it technically still equals 0. Okay, I'm going to rewrite what we had. So now, remember, I want to isolate the variable. So the way I do this is I need to move everything away from the variable. So I have a negative 12x, I make it a positive 12. So now I have 12 equals negative 4x. And now I can divide both sides by negative 4. So I can get my answer of negative 3, which is the same answer I got over here. So as we can see, students tend to make this mistake. It's not best practice to cancel out, to completely cancel out a side. You don't want to end up having 0 here. This is not the best way to do this. Alright, and now we're going to look at an example where it gets even more complicated because of the way it looks. So just bear with me here. So I have 7x equals 9x plus 36. Okay. So this is where it gets a little trickier. And again, I'm going to do a T-chart because we are going to solve this 2 different ways. So as we said in the past, let's focus here. As we said in the past, we scan the problem to see if we can combine any like terms. On the left side, there's no like terms. On the right, we can't combine these. These are not like terms. So then we said we should always move the smaller variable over first. Now, this is one of those exceptions to the rules. Because if I move this positive 7 across the equal sign, I must make it negative 7x. And what I do to one side, I must do to the other. Now, look what happens. The same thing as in the last question. Since these are opposites, they cancel, they equal 0. I must actually put a 0 here as a placeholder. You can't just leave it blank. And then I complete this side. Now, we don't get to just simply ignore this side and say, okay, I'm going to divide both of these numbers by 2 and get x equals 18. I cannot do that. Remember, you can only finish solving an equation with division if they're on opposite sides. Remember, our goal is to get x by itself. So the way I can do that is move everything away from the x. So I have a positive 36. I'm going to subtract 36. 0 minus 36 is a negative 36 equals 2x. And remember, you can always pause these videos if you want to take it a little bit slower, or if you need an extra minute to process what we're doing. Alright, now again, we want to isolate the x, or get x by itself, but the 2's in the way. We always divide last. Remember, you always divide by the coefficient in front of the number. So now x equals, and we have a negative divided by a positive. Remember, you can use the triangle, cover them up, negative and positive, and I end up with a negative. 36 divided by 2 is 18. So x equals negative 18. Now, again, this is not the best practice because you're essentially canceling out a complete side. You don't want to do that. You do not want to do that. So in this case, when I said always move the smaller variable over first, there is an exception to that rule, and this is the exception. If a situation is going to occur where a side will be completely canceled like this, when you end up with 0 here, it's not best practice to move the smaller variable. So here the 7x is smaller, but we don't want to move this over here because then they're going to cancel out a complete side. So in this case, we need to kind of take the exception to the rule and perform the opposite. The opposite, or the inverse, of a positive 9x is a negative 9x. What I do to one side, I must do to the other side. So now we look at this and we use the integer rules. Different signs, so I subtract, and then I take the sign of the higher number, so it's a negative, equals, then what's left is a 36. And now we always have to divide both sides by negative 2 because that's our coefficient. Another common mistake students make is when they have a negative here and they're dividing, they think they change it to a positive. You don't do that. You must leave it as a negative. Remember, when you divide, you don't change the sign. Okay, so positive divided by a negative is a negative, and then we get 18. So this is what we call best practice, where we do not end up canceling an entire side out. We don't want to end up with 0 on a side. So I would recommend that in these situations, this is the exception to the rule that you should always move the smaller variable over first. Okay, thank you, and stay tuned for another episode.